at multiplying algebraic fractions. So all of these examples have the variables in the numerator, but even if it was in the denominator, the procedure would still be the exact same thing. So no need to fret or worry. Say, why is it that the numerators only have the variables and the denominators doesn't have any? It's because the procedures are the exact same thing. So let's go through now. So this is a simple one with only one variable. This has two variables. This has a variable and a constant attached. Same thing, a variable and a constant with a variable and a constant. So the procedure, it's the same thing as when you're multiplying normal fractions. The numerators will multiply each other and the denominators will multiply each other. So in this particular first example, equals, so it would be the numerator, so 3 times 2x, and that would give you 6x. Then you just simply put your multiplication, your fraction bar, then you say 4 times 5, and that gives you 20. And that's it. You would have worked out the first question by simply multiplying your numerators and your denominators. Second question, 4x over 6 times 5x over 7. Procedures are the same thing. Just like when you're dealing with ordinary multiplication of numbers or of terms with variables, you will multiply the number part. So 4 times 5, that gives you 20. Now the variable section, so it's x times x, and x times x gives you x squared. So you put your fraction bar. 6 times 7, that gives you 42. And that's it. Now, for this particular question now, these only had one single variable without anything being added to it. Now, this has something added to the variable. So, for you to work this out, you have to use the distributive property. So, equals, it's 5 times everything on this side. So, it would be 5 times x first, and then 5 times the next part. So 5 times x gives you 5x. Then you put back whatever sign is in between, so plus, and 5 times 1 gives you 5. All over 6 times 3 gives you 18. And that's it. So now we go to the next part. X plus 1 over 7 plus x plus 3 all over 2. Distributive property once again. So you can imagine that this is bracketed. Then you apply your distributive property in order to answer it. So it would be the x multiplied by both items in the bracket. So it's x times x to give you x squared. Then it's a plus 3, so you put back your plus, and 3 times x gives you 3x. Now, this part says it's a plus 1. So you put back your plus 1, so it will now be 1 times x and 1 times 3. So 1 times x or positive 1 times positive x gives you a positive x here. Then the next one is 1 times positive 3 to give you a positive 3 there. And you put that over the denominator, which is 7 times 2 gives you 14 equals. Once you get to this part, you have to do the same rules like you would have learned about simplifying expressions, because you search for what is common between each other and add them. So x squared, none of these other terms are squared, so are x squared. So you put back your x squared by itself. Now 3x, you have a single x just with the same degree of power. So it's 3x plus x, and that gives you 4x. Plus, you have nothing, no other constant in this expression. So you just put back your plus 3 all over the denominator. So that's the procedures for dealing with multiplying algebraic fractions. Now, all of these questions on this side had a plus in it, but if it was not a plus sign and rather a minus sign, the procedures are the same thing. It's just that you will just have to remember how to operate with integers. when you are dealing with it. So if it was a minus here, it would be negative 1 times x gives you a negative x here. If it was negative 1 times positive 3 would give you a negative 3. So that's all the difference between having a plus sign in between versus having a subtraction sign in between. So I hope this video would have assisted you in better being able to multiply algebraic terms. And just keep practicing and you will become better at the concept. Thanks for watching and tune in again with Mr. Brown.